Hello, myself Mr. Kishore Kanse. I heartily welcome you all in Shivanya classes digital platform. Today we are going to discuss topic ionic equilibrium from the class 12 standard. The syllabus or points are framed in this video is as per the Maharashtra State Board syllabus. Content or points in this topic are: first is introduction, second is types of electrolytes, third acids and bases, fourth ionization of acids and bases, fifth atoionization of water, sixth pH scale, seventh hydrolysis of salt, eighth buffer solution, ninth solubility product, and 10 common ion effect. In first video we discussed about first 3 points, that is introduction, types of electrolytes, and acids and bases. In this video we are going to discuss from the point number 4, that is ionization of acids and bases, atoionization of water, pH scale. Okay, point number 4, ionization of acids and bases. Before we starting with the point, what do you mean by the bases? The bases which have hydroxyl group in, or which donates, which accepts proton, or which donates lone pair of electron are called as a bases. What do you mean by acids? Acids which contain hydronium ion or H plus in their structure, the one who donates proton and one who accepts lone pair of electrons are called as acids. What do you mean by ionization? Ionization means molecules are dissociated and converted into the ions. It's called as a ionization. In last video we discussed about electrolytes and non-electrolytes. Electrolytes are two types, that is strong electrolytes and the weak electrolytes. The strong electrolytes are strong acids and strong bases. Weak electrolytes are weak acids and weak bases. Here we discuss about acids and bases. Acids are mainly two types. First is the strong acids and second one is the weak acid. Strong acids, the acids which dissociate completely or almost completely, is called as a strong acids, and the acids which dissociate in small extent is called as a weak acid. Here we will discuss the examples. The examples of strong acids are: first is hydrohalic acid, hydrogen, halic halogen, so it is HCl, HBr, HI. Hydrochloric acid, hydrobromic acid, hydroiodic acid किंवा hydrogen chloride, hydrogen bromide, hydrogen iodide. From the halogen derivative, one remaining, that is fluorine, that is HF, which is a weak acid. Remaining 3 is the strong acids. Second strong acid is oxacids, in which number of O atom exceeds the number of ionizable H atoms. Number of O atoms exceeds the ionizable H atoms. Here there is a 1H, 3O, 2H, 4O, 1H, 4O. The examples, so the finally examples of strong acids are hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, sulfuric acid, perchloric acid. Now the second, that is weak acids. Weak acids, hydrogen fluoride. Second, the acids in which H is bounded to O or halogen, for examples HCN or H2S. Third is oxacids, in which O is equal or exceed by 1 with the number of ionizable hydrogen atoms. Here difference between hydrogen and oxygen is 2. Here difference between hydrogen and oxygen is either equal or exceed by 1. So it is HClO, HNO2, H3, PO4. Then organic acids such as acetic acid, benzoic acids are the examples of weak acids. Now about the bases, same like acids, strong bases are the bases which dissociate completely. Weak bases are the bases which dissociate in a small extent. The strong bases examples are either M2O or either MOH, where M stand for the group A elements. The examples are Li2O, Na2O, K2O, Rb2O, CS2O, or LiOH, NaOH. NaOH commonly we know the strong base. Second is MO or MOH twice. Here M is considered for the group 2A2 metals like calcium, selenium, barium. MgO and MgOH twice are the only slightly soluble, but soluble portion dissociate completely. Next is weak bases. Weak bases, many compounds with electron rich nitrogen are the weak bases. Examples are ammonia and amines. Here ethylamine, dimethylamine, tripropylamine, pentylamine or pentylamine. So these are the examples of weak bases. So read carefully, understand the examples, because in the further topic we have to know which are the strong acids, weak acids, strong bases and the weak bases. Next point is dissociation constant of weak acids and weak bases. Dissociation constant is indicated by Ka for acids and Kb for the bases. The dissociation of weak acid Ha in the water is expressed as, dissociation of weak acid Ha is expressed in this reaction, where Ha is the undissociated molecules which are converted into ions like H plus and A minus, where BOH is the weak base which is unionized base molecules which is dissociated into B plus and OH minus ions. Equilibrium constant called acid dissociation constant Ka for this equilibrium is, so Ka is concentration of ions divided by concentration of undissociated molecules. So it is H plus concentration of A minus divided by concentration of Ha, which is the formula for dissociation constant of acid. Same way for the base, Kb is the dissociation constant. It is the ratio of concentration of ions divided by concentration of unionized molecules. So Kb is equal to concentration of B plus O minus divided by BOH, concentration of BOH. Dissociation constant of weak acid or a weak base is defined as the equilibrium constant for dissociation equilibrium of weak acid or weak base respectively. So here we have to understand the formula for Ka, which is the dissociation constant of weak acid, and formula for Kb, which is the dissociation constant for the weak base. Now next point is Ostwald's dilution law for the weak acid Ha. In further slide, Ostwald dilution law for the weak base BOH. So question is, derive Ostwald's dilution law for the weak acid Ha. For that, firstly write the reaction or dissociation of weak acid Ha. The reaction becomes Ha is converted into H plus plus A minus ions. Dissociation constant Ka is concentration of these two divided by concentration of Ha. At equilibrium, the amount present at equilibrium in moles is degree, alpha is the degree of dissociation. So H plus is the alpha, A minus is the alpha, HA, amount of HA at equilibrium in moles is 1 minus alpha. The concentration at equilibrium mole per dm cube is 1 minus alpha divided by V, alpha divided by V and alpha divided by V. So place these values in equation Ka. So concentration is C multiplied by alpha. So concentration of HA, H plus is equal to C alpha. Concentration of A minus is equal to C alpha. Concentration of HA is equal to C 1 minus alpha. By cancelling C to C, the Ka remains C alpha square divided by 1 minus alpha. So alpha is equal to under root of Ka by C. The reason is because HA is the weak acid, alpha is very small, so 1 minus alpha becomes 1. So Ka is equal to C alpha square is equal to Ka by C, and alpha is equal to under root of Ka by C. Also C is equal to H plus by alpha, so H plus is equal to C alpha. In place of alpha, place H plus divided by C. You will get equation H plus divided by C is equal to under root of Ka by C, and final equation becomes H plus is equal to under root of Ka C. Ka is equal to C alpha square and alpha is equal to under root of Ka by C. This is Ostwald dilution law for the weak acid HA. Now next, Ostwald dilution law for weak base BOH. Follow same. Write first dissociation reaction of weak base BOH, that is BOH gives B plus O minus ions. Calculate dissociation constant for weak base Kb, that is concentration of B plus multiplied by concentration of OH minus divided by concentration of BOH. Amount present at equilibrium is 1 minus alpha. Concentration of B is alpha, concentration of OH is alpha. Amount divided by volume, that is 1 minus alpha divided by V, alpha by V and alpha by V. So Kb becomes C alpha into C alpha divided by C under root of in bracket 1 minus alpha. Here also the equation becomes Kb is equal to C alpha square divided by 1 minus alpha. BOH is also a weak base, so alpha is very small, so 1 minus alpha is considered as a 1. So equation becomes Kb is equal to C alpha square. Alpha is equal to under root of Kb by C, where alpha is equal to OH minus divided by C, and equation becomes OH minus is equal to C under root of Kb by C is equal to under root of Kb multiplied by C. So this is formula for Ostwald dilution law for the weak base, that is BOH. Next is ionization of water. Ionization means dissociation or conversion into ions. By self ionization, ionization of whom? Of water, which is H2O. It means whenever you place this word ionization of water, water react with water. So H2O ionize with H2O, we will get the ions H3O by acting one H2O molecule as an acid and OH by acting one water molecule as a base. So Kc, which is the dissociation constant, is the product of concentration of ions divided by the product of concentration of undissociated molecules, that is Kc. This H2O square, concentration of H2O square, here is the divide. Whenever go to the another size, it multiplied, so it is Kc H2O square, the ionic product of water, that is Kw. So Kc H2O square is equal to Kw is equal to H3O plus OH, and the value is 1 into 10 raised to minus 14. So equation for ionic product of water is Kw is equal to concentration of hydronium ion multiplied by concentration of hydroxyl ion, which is 10 raised to minus 14 at 25 degree Celsius. What it means? Ionic product of water. Which are the ions of water? The ions of water are hydronium ion and hydroxyl ion. Its concentration and its product. So ionic product of water indicated by Kw, and which is 10 raised to minus 14. So if we separate out, in pure water concentration of hydronium ion and hydroxyl ion becomes equal. So it is 1 into 10 raised to minus 7. The product of molar concentration of hydronium ion and hydroxyl ion at equilibrium in pure water at a given temperature is called as ionic product of water. Definition. Let's see again definition. Product, multiplication, molar concentration of hydronium or hydronium ion and hydroxyl ion at equilibrium in pure water at a given temperature is called ionic product of water. Okay, don't need to recall, this is just understand or by heart the formula. Kw is equal to product of molar concentration of hydrogen ion and hydroxyl ion of pure water in a given temperature is called as ionic product of water. Next point is pH scale. What do you mean by pH? What do you mean by pOH? Before starting, we'll understand. Definition of pH is negative logarithm at the base 10 of hydronium ion concentration, and pOH is negative logarithm at the base 10 of hydroxyl ion concentration. What it means? Means if the concentration of H plus ion in a given solution is more than 10 raised to minus 7, then it is said to be acid. If concentration of H plus ion is less than 10 raised to minus 7, it is said to be basic. In simple words, if concentration of H plus ion is higher, solution become acidic. If concentration of OH minus ions is higher, solution becomes basic. And when it is equal, solution becomes neutral. So pH scale. pH scale is the one scale representing the number line from 0 to 14. From that, 7 is the neutral number where the pH is neutral. What it means? At 7, concentration of H plus ion is 10 raised to minus 7. Concentration of OH minus ion is 10 raised to minus 7. So concentration of H plus and OH minus is 7. It means it is a neutral. from 7 to 0. From 7 to 0, acidity increases. It means concentration of H plus ion increases. From 7 to 14, it becomes basic and concentration of H plus decreases and concentration of OH minus ions increases. Here are few examples with their pH. Lye have the pH 13, ammonia is the 12 basic pH, baking soda is 8.5 which is also a basic, human blood is 7.5 which is a basic, milk is less than 7 so slightly acidic, tomato juice is 4.5 acidic, battery acid is the pH 1 which is strongly acidic, and the remaining examples. Now also the relationship between pH and pOH is pH plus pOH is equal to 14. Why the pH scale is of 14? Because the concentration of H plus and OH minus ion is 10 raised to minus 14, and at 7 concentration becomes same, hence pH scale started from the 7. Okay, let's see once again. Straight line. 7 is the neutral, above 7 is the more basic, below 7 is the more acidic. Here is also the few examples representing their pH. In this chart, H3O and OH minus ion, when concentration of H plus is greater than OH, solution becomes acidic. When concentration of OH is more than H3O, solution become basic, and concentration of H plus and OH is equal, the solution becomes neutral. Let's see another way. Here is the pH representing from the 1 to 14 up to 15. At 7, here is the concentration of H3O plus ion. Here the concentration of OH minus ion. So it becomes equal. For acids, concentration of H plus increases, and for base it is decreases. Same way for acids, concentration of OH minus ion decreases, and for the bases its concentration is increases because of negative sign. If the numbers raised to numbers increases, it becomes actual value is decreases. So it becomes, here is the another diagram of pH scale. What is relationship between pH and pOH? Before that, first write the formula for pH. Negative logarithm at the base 10 hydronium ion concentration. Then formula for pOH, negative logarithm at the base 10 of hydroxide ion concentration. From the previous slides, ionic product of water is the product of molar concentration of hydronium ion and hydroxyl ion, which is 10 raised to minus 14. Taking logarithm of both sides, it becomes log H3O plus log OH minus is equal to log 10 minus 14. Then taking base 10, log base 10 H3O plus log OH minus is equal to minus 14. By sign inversion, we will get minus log H3O plus minus log OH minus is equal to 14, where minus log H3O plus is the pH and minus log OH minus is the pOH. So pH plus pOH is equal to 14. So thank you for watching video. If you are new on this channel, please like, share and subscribe our video or channel. Thank you one and all.